Okie dokie, folks. This is our last part for the dry type transformer. um, what we need to find out now, we found out the size of the fuses. Over here, we found out the size of the fuses, size of our conductor size over here, and our conduit size, as well as our secondary conduit and conductor, and the size of our load center. So the only thing is missing, which is a very important part, is going to be our bonding conductor. So basically a bonding conductor is installed into this, and then it's installed on the XO of our transformer, and from our bonding jumper then leaves to go out to our load center. The rule has changed. Previously we used to have to bond this to the ground. However, that's been changed. Now it's directly to the XO of our transformer. So that's basically what we're doing. We are going to take a look at a couple of rules and to find the bonding conductor size here, bonding conductor size here, as well as the jumper that goes from our bonding to the XO of our transformer. So let's see if we can find oh, my camera is. There you go. Focus. Bonding conductors, we are using section 10 in our code book, more specifically 10-616. Subrules 1 and 3. And starting off, and also item A in subrule 3. So let's write this down here. 3A. So for the first step, step 1, the bonding conductor on this side here is based on our fuse size of our primary overcurrent protection, and our fuse size, if you remember, is 50 amps. So step 1 is based on a fuse, or our fuse that's protecting the system, which in our case was 50 amps. And then step 2, we go to table 16. And look at the table, and the table would say, give me a second here. Man, why is my camera going out of focus? Table 16. Table 16 tells us the ampere rating or setting of our overcurrent device protecting conductors on the of our equipment, etc. And you see, then underneath that it says not exceeding. So we do not exceed this 50 amps here. So we scroll down and we see the 20, 30, and then the 60. We don't use the 30 because it's too low, and we don't go above 60, so we have to use the 60. So we can either use so on this side over here, it was copper, number 10 for copper, aluminum, number 8, aluminum. So that's our first step. Carrying on, step 3, if you like. We are looking for the bonding conductor size over here. And again, we're using the same rule. However, this time we have to, so this is based on 10-616 subrule 3, item A. This is the same rule, however, we must go to Appendix B. Appendix B. And basically what Appendix B is telling us, that we have to use our voltage ratio times our fuse, like we did in our previous example. So our voltage ratio, primary and secondary. So use voltage ratio. Multiplied by the voltage ratio. Oh, sorry, multiplied by the overcurrent size fuse, in which overcurrent. So in this case then, let's call this step 4 if you like. Our voltage ratio is 600 over 208 times 50. And I believe this worked out to be 2.8 from previous. Where's my calculator? 600 divided by 208 equals 2.8. That's 2.8 times 50, which equals 144 and change, but let's round it to 144. Step 5, go to table 16, and now we are looking for not exceeding 144. And we should have, it goes from 20 to 30, 60, 100, 200. We cannot go down to the 100, it's too low. So we have to choose the 200. And again, so for copper, number 6, copper, or number 4 for aluminum. Last step is to find this little jumper here, which is step 6. Oh, let's just change the color here. Break it up. Step 6. 10-616 subrule 1 basically is telling us again to use the voltage ratio times the fuse. So our bonding jumper here is going to be the same as this guy here, number 6. So again, the voltage ratio times our fuse. Again, the exact same thing we did there, 600 over 208 times 50. And again, we end up with 144. Go to table 16. And number 6. Number 6, copper. And what was it? Number 4, aluminum. So it's basically the same. Doesn't change. And that's it. Okay, so the next bunch of videos that I'll be doing will be on liquid filled transformers under 750 volts and over 750 volts. So stay tuned.